When you look at a glass of wine, you're not just seeing fermented grape juice, not even close. You're actually looking at a complex chemical symphony. But how does a winemaker control that symphony? Well, it turns out it's a lot less about magic and a whole lot more about science. So let's get into it. We're going to uncork the science that transforms this simple fruit into a stable, delicious, and honestly fascinating beverage. What secrets are really hiding in your glass of wine? Okay, so before a winemaker can even think about making wine, they need what's essentially a chemist's toolkit. This is where oenological analysis, that's the fancy term for the science of winemaking, comes into play. Think of it as the set of instruments they use to guide the entire process with incredible precision. And believe it or not, this right here is the universal blueprint for pretty much any chemical analysis. So for a winemaker, the problem might be something like, okay, how much sugar is in these grapes I just harvested? From there, they follow these exact steps. Take a sample, prep it, calibrate the gear, measure, and boom. They get the results, the raw chemical information they absolutely need to make their next big decision. So our first stop is right at the very beginning of the whole process, analyzing the raw grape juice. It's called must. And this is the winemaker's first real chance to, well, read the future of the wine. The very first and maybe the most important reading they take is something called degrees Brix. It's really just a direct measurement of how much sugar is packed into that juice. Now, why does that matter so much? Because that sugar, that's the fuel. It's what the yeast is going to eat to create alcohol during fermentation. And check this out. This is what's so cool about the science. By measuring the Brix, a winemaker can plug it into a simple formula like this and calculate the potential alcohol content of the finished wine. This is before a single yeast cell has even touched the juice. It's kind of like knowing exactly how tall a building is going to be before you've even laid the foundation. It's amazing. But of course, wine isn't just about alcohol, right? The next crucial measurement is total acidity. Now, this is the collection of good acids, things like tartaric acid, that give a wine that bright, crisp flavor and all-important structure. This is the acidity you want. And I want you to keep that in mind because this distinction is about to become very, very important. All right, let's fast forward. The yeast has done its job. The fermentation is done. Now the analysis totally shifts. We're not predicting potential anymore. We're making sure the final product is stable, it's safe to drink, and of course, that it's delicious. So, remember all that potential alcohol we calculated earlier? Well, now it's the moment of truth. We have to confirm it. We made a prediction, and now we've got to measure the real thing. So how do they do that? Well, one of the most common tools is this little guy, the ebullimeter. And it's such a clever device. It works on a really simple principle. Alcohol boils at a lower temperature than water. So, by measuring the wine's boiling point with incredible precision, the ebullimeter can calculate the exact alcohol percentage. Simple, but effective. Okay, so the alcohol is where it should be, the good acidity is in place. Now the winemaker has to play defense, because there is a villain, a chemical villain, lurking in every barrel just waiting for a chance to ruin absolutely everything. And here it is. Meet the antagonist, volatile acidity. This is almost entirely made of acetic acid. Yep, the exact same compound that's in vinegar. It's the #1 sign of spoilage, and it gives off that sharp, pungent smell that just screams, this wine has gone bad. This is the acidity you absolutely, under no circumstances, want in your wine. So, to hunt for this villain, chemists use special equipment like this, the Cazenave apparatus. What it does is it essentially boils off and separates these nasty volatile acids so they can be measured. This lets winemakers catch any spoilage really early, before it has a chance to get out of control. So let's just put our two acids right next to each other. It's a real hero versus villain story. On the left, you've got total acidity. That's our hero. It gives you that desired bright, tart flavor and structure. And on the right, you've got volatile acidity, the villain. It creates that awful vinegar smell and means there's a major flaw. One is a critical part of the plan, the other is the enemy that must be stopped. So if you've got a villain, you need a protector, right? Well, how do you protect the wine? The most important preservative is sulfur dioxide, or SO2. It basically acts as a guardian, protecting the wine from all the nasty bacteria and wild yeasts that could produce that dreaded volatile acidity. It is absolutely crucial for stability and making sure the wine lasts. So when all the tests are finally done, what are you left with?
You have a complete chemical profile, a totally unique identity for that specific wine. It's like a final report card.
And this is basically what that report card looks like. For a typical dry wine, you'll see the final ethanol percentage right where you want it. The good total acidity is in that healthy range, the bad volatile acidity is kept super, super low, and you even measure any leftover sugars. Together, these numbers are what define the wine's balance, its quality, its very character. At the end of the day, winemaking is this incredible dance between art and rigorous science. You have the passion and intuition of the winemaker, but it's all guided by hard data from the lab. Every single bottle has its own unique chemical fingerprint that really does tell the story of how it was made.
You know, that bright acidity on your tongue, that warming feeling from the alcohol, that clean finish, that is not an accident. That is chemistry, plain and simple. So the next time you pour yourself a glass, just take a second and think about its chemical fingerprint. What story is it trying to tell you?